Here is an explanation for the answer to final exam question number 27 in Electronics Demystified, 2nd edition. If you have the printed version of the book, you'll find it on page 422. If we connect a battery and a resistor, here's the battery and the resistor, in series with a semiconductor diode, so that the positive battery terminal goes to the diode's cathode and the negative terminal goes to the diode's anode, we will always have a condition of what? Well, here's a milliammeter in series with this system, which will indicate no current. That is a condition of what we call reverse bias, and we will always get that condition if we connect a battery so that the positive terminal goes to the diode's cathode. Okay, well, that's just great. Let's look a little more closely at what actually happens in a semiconductor diode with forward voltage and reverse voltage. Now, the correct choice to this question is C. We have a condition of reverse bias, which is the entire part of the characteristic curve to the left of the vertical axis in this graph. Reverse voltage causes a variety of phenomena to happen in a semiconductor diode, depending upon how great that reverse voltage is. The other choices we have are A, avalanche breakdown. That is this condition right here in the characteristic curve. That is where the reverse voltage is so great that current actually begins to flow in the diode. It overcomes the avalanche point in the diode and causes current to actually flow in the reverse direction. But we don't always get that condition. We only get that condition if we exceed the avalanche voltage. So choice A is wrong. Choice B, forward breakover. Forward breakover is this condition in this part of the curve. That is where forward current actually flows. We are forward biasing the diode, not reverse biasing the diode, and that happens when we connect the negative terminal of the battery to the cathode of the diode rather than to the anode of the diode. So choice B is not correct. Again, choice C is our answer here. We always have a condition of reverse bias. Rectification and saturation, choices D and E. Well, rectification is something that we need to do, that we would need to apply alternating current to the diode in order to get, and then we would be operating in this region of the diode's characteristic curve. We might the current might alternate between here and here, say, and so we would get rectification. But we won't get that if we apply a direct current in the reverse direction. Saturation. Well, now that's an interesting case, because if we were to continue with this characteristic curve, we would eventually reach a point at which the curve would level off like this. This condition right in here where the curve is level is saturation. That is what saturation is, but that requires a forward bias. So once again, the correct answer to this question is C.